Yep, that's me. You're probably wondering how I ended up in this situation.
Nothing. That's right. I just fell asleep waiting for my print. Now that I'm awake, welcome to my space. I'm Man, and over here we'll be building on ideas generated by those dumb yet overconfident intelligence, my brain. So this idea started from Lychee AI's Isaac Sim tournament. The challenge was pretty simple: build a mobile vehicle robot in Isaac Sim or Isaac Lab. There were only two rules: that it should use articulations and it should have wheels that are stable enough to drive on. So I started googling for some ideas so that I can get some inspiration for the mobile robot. I've worked on rovers in the past, but their design seems too simple for this competition. And I was leaning more towards quadruped with wheels, but given that I started just 2 days before the deadline, there seemed to be too less of a time to train a proper quadruped robot. So I turned to ChatGPT for some help in ideation. It gave me a good category that I would like to focus on, the deformable one. So I searched more about it and came across two designs: NASA's deformable wheel that's more adaptable to the terrain, and a TriStar wheel configuration which will help the robot climb stairs and obstacles. So I thought, why not merge both of them? A wheel that's deformable and can help climb obstacles. So now that I know what I need to build, I started with designing the wheels. I used Fusion 360 for it because I've used it once before for a small project, and I know CAD a bit. I've taken a course in my undergraduate studies. Right now, I only wanted the wheels to work in simulation, so I did not pay much attention to the physics parts of it, just like any other CS guy. This was the first mistake that I made. Isaac Sim also has physics in it. Designing the robot was the easier part. I got done with it within a few hours. As you might have guessed, it didn't work.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
After setting things up in Isaac Sim, the simulation just didn't work. Whenever I tried to play the sim, the wheel did not spin and it seemed as if the spokes were being pushed out. I tried playing around with the stiffness, the damping and all other articulation factors, but it just did not work. I tried disabling all the other spokes and just playing around with a single or two spokes. Maybe it's like the weight that's causing the issues or something like that, but it wasn't even that. Turns out the solution was quite simple. You just need to ignore the stiffness, basically make it 0 and make damping exponentially higher. I kept it at 10,000 and now the wheel was spinning quite nice. The rest of the things went by pretty smoothly. I used Blender to mock up the environment and use it in Isaac Sim, and was able to get up a demo video that I submitted to the Isaac Sim challenge. I won the 3rd place. This calls for me to make it for real, but the simulation model will not work because I ignored physics while making it. So time to remodel. I wanted this mechanism to be controlled by a single motor, just cause it's cheap. So during my Google search, I came across this 8-bar parallel linkage mechanism, but it's too mechanical for me to understand how to build it for myself. Enter a piston. Within the engines of cars, we know how these pistons work. The piston moves vertically and it has a pivot that has a rotatory motion at its bottom. This is similar to what I wanted in my mechanism as well. I just have multiple pistons connected to the same center axle. This mechanism is called a slider crank mechanism. I did not know this before my Google search, so we learn something new every day.
5 hours later.
So I've completed the design now for the wheels, and I see so a lot. I should put a counter down in the next video. But anyways, I've completed it, and so this is what I'm focusing on. And yeah, you can see that it's not exactly symmetrical. The center, the plus ones are a bit towards the center, while the X wings are a bit towards the edges. I just wanted it to have be like that, so that the longer slant wheel patches, they retract at a much faster rate than the vertical one, because when it crumbles down, it will only be supported by the plus positive, like the vertical spokes, rather than the slant spokes. The slant spokes are only to fill spaces once once it expands. Now I need to make it a bit supportive. So like right now the wheel patches are just hanging there in the air, and like in order to actually restrict its motion in a linear way, I'll need to create the slider. So I'll work on that now, and yeah, it should be done within a few minutes. So I'm done with the entire mechanism. I'd say like the entire wheel is ready now. Probably I could just 3D flip it to 3D print. My printers arrived as well, so I can use that. I'll show you. This is how it looks. I think this might cause a few issues based on like the strength and the thickness of the rods, the connecting rods that are there, but I'll print it once and see what happens. Cue the montage. So the print is completed now, and I have all the parts, and I tried assembling them. So this is what the backside holder is for the slider, and this is the spoke that goes inside over here, and like it restricts it. But there are a few issues with it. So this is what our actual spinning, like the crank is, and this will attach over here. But the thing is, this itself is too weak. I have used bearings inside of it, but it breaks while spinning, and I can't make these walls thicker because otherwise it would limit the distance that I would get while rotating the crank. So I think I'll have to redesign that entirely, and this won't work. And yeah, that was not the only issue. Even these rods that are connecting the spokes to the, I don't know what I call this, but even they break while spinning. So I think I'll have to redesign it as a whole. I'm thinking of bypassing this bearing requirement and maybe just creating like a claw-like mechanism so that it just snaps directly onto this, and I don't need to extend it this big to get the distance. So first design has failed for now, and it will take me some time to work on a redesign because I have other interviews and all coming up. So yeah, so this is where the project is right now, and 3D print kind of works, but it's too weak, and I'll need to redo the design and get back to it. So in the next video, I'll be jumping into redesigning the mechanics and hooking up the electronics. So if you want to see whether this robot actually drives or if it will break again, stick around and I'll catch you.